Hello, everyone. I am pleased to welcome you to this auspicious event, which marks the kickoff session of a series of presentations by the magnificent interns in the Hamoye Data Science Internship, Winter 2022 cohort. My name is Chigozen Bon, a data scientist at Hamoye AI Lab, and I would be your host. I am exhilarated to be a part of this remarkable event today. I'm joining this call from Lagos, Nigeria, and trust me when I say there is no better way to end your week than enjoying these stupendous presentations by our true MVPs. Our beloved and dedicated interns have worked within a learning community on different data sets, applied several machine learning and data analysis tools, and have come up with solutions which I can't wait to see them show us. They have tested and validated their solutions in real life, and here today, they are ready to blow the minds of our incredible judges, members of data science communities, and all of us here present. We want to also use this time to welcome Hamoye alumni, Hamoye fellows, and all of us that have come to enjoy a machine learning weekend with Hamoye. Our judges are prestigious machine learning professionals that have coordinated and completed several real-life machine learning solutions and systems. Allow me to introduce to you Shivam Singh Rathore, a lead data scientist at the Hamoye AI Lab. He is also an Hamoye fellow. Shivam holds a Master's of Technology MTech degree in Artificial Intelligence and advanced certification in Data Science and AI at India Institute of Technology, Madras. His research areas include NLP and Kafka, InfluxDB, ML algorithms, data analysis, and financial data science and Android developer. Our second judge for the day is none other than Damilola Shobowole, who is a data scientist at Maven Code LLC, South Lake, Texas. Damilola and Maven Code focus on generating solutions around AI, ML, distributed programming, Scala, Python, Golang, consulting, etc. He's also a Hamoye fellow and works as a front-end and web developer at Hamoye AI Labs. Can you permit me to mention that these Dexterox judges they were both interns in the HDSC 2020 and have many times testified to owning their boisterous career to the internship and all its learning modules. Before we proceed, there are a few housekeeping rules we expect to keep in mind throughout this presentation. Should you need to speak, please raise your hand and you'll be unmuted. Presenters for every group are expected to use their full name as their Zoom display name. You may post your comments, ask questions, and share how you feel on the chat boxes on Zoom and on YouTube. Best wishes to the presenters, and without any further ado, I would like to call on the first team presenting today, ADA Boost, Team 1, who is to be presented by Hassan Ademola. Thank you. Hassan.
Hello. Hello, good morning.
Good Hello, afternoon. Good afternoon.
Can you hear me, please?
Yeah, you're audible.
Sure.
All right. Are you ready for your presentation?
Yeah, yes, I am.
All right, your time starts.
Can you see my screen?
Yeah, please go ahead.
All right. My name is Hassan Ademola, and I'll be representing Team ADA Boosts and presenting about the men's basketball sports. So the content of this presentation is the overview of basketball, the analysis of the historical data, model building, and results and conclusion. Start on the overview. Basketball is a high-scoring sport in which two teams, usually of 5 players, battle on a rectangular court with the primary aim of shooting through the opposing team's baskets. The NBA is the most significant sport in the professional basketball league in terms of wages, talent, and level of competition. So this presentation focuses on the NBA. The problem statement, this is what we are aiming to solve. This project aims to investigate the most essential regular season metrics that contribute to a team's chances of making the NBA playoffs final. So to give a context, to give an explanation of what the playoffs is, the NBA is basically divided into two conferences. The East conferences. So each conference consists of 15 teams. The playoffs consist of the best 7 teams in each conference. So they battle it out in their respective conferences, and the winner for each conference is going to compete with that of the other for the NBA championship. So going to the EDA, our data was sourced from Cargo. So it consists of 1,536 rows and 60 columns. Each row represents a team's regular season metrics for a particular year. So this is the representation of the data for each league. So this represents how many unique teams we have for each basketball league. So as you can see, we have over 60 teams for the NBA. And we also have we have about 6 leagues in the data, 6 unique leagues in the data. So the distribution of the NBA data. This data spans between 1946 and 2011. Starting, we can see we have more teams. Looking at this distribution, we have more teams in the as the league progressed, we had more teams. So in the history of NBA, we've noticed that a lot of teams really merged, a lot of teams really joined the NBA later on. So the ABA and the NBA also merged later. They also merged in 1986, I think. Going to this, looking at the how the data is the representation of both conferences in the NBA data, we can see we have fairly equal amount of records for both conferences. So how many teams have won, which teams have won the most NBA titles? This chart represents that. We can see that Boston Celtics and Los Angeles Lakers have won a very high amount of the NBA titles. Boston Celtics has won 17, while Los Angeles Lakers have won 16. So it will be interesting to point out that Los Angeles Lakers represents the Western Conference, while Boston Celtics represents the Eastern Conference. What's the number of NBA champions from each conference? We can see that both conferences have produced fairly the same amount of NBA champions. So we can also see that we only have about 41 NBA champions in these charts. This is because many divisions later merged to become a conference. So not all records have a conference. Not all record was split into a conference. So talking about the field goal,
you have less than a minute.
Less than a minute. Yeah, talking about field goals. This is the number of goals the team attempts outside free throws. So we can see that over the years, teams have been attempting less free goals, but their conversion accuracy has improved. Free throws is like a penalty in the basketball. You can see that less free throws have been awarded over the years, while teams have been improving their free throw accuracy. You can also see trees. This is a 3 points that is thrown outside the 3-point line. Teams have been attempting more free throws as time went on, and they've also been improving their trees conversion. Personal fouls, they've been converting less fouls, they've been committing less fouls, they've been accumulating fairly almost the same points. There has not been like a clear distinction between points then and now. So, but we can see that there's a more competition recently than before. So far we can observe that play style in NBA has
round up.
Okay, we can observe that play style in the NBA has evolved over time. Teams are making more field goals and commit less fouls. So the play style and technique has improved overall. Talking about the models, we have imbalanced classes due to we can only have one NBA champion for 1 year. So this explains why we have a class imbalance. So training on these classes, we can see our model performed very poorly. We undersampled the majority class and trained again. We can see the model has improved a whole lot. Recall and precision has also improved. So we also engineer some other features and find out that our boosting algorithms do very well. These are all assembled models. So checking about the feature importance of these models, we can see when patterns and the performance of the opponents contributes to how far a team can go in the NBA. So this is
Skip
how
to your
we
summary. Skip to your summary. Round up.
All right. What I'm saying is essence is that most models capture 60 to 70% of the positive and negative classes respectively. However, the models struggle to distinguish between the classes. This is why we have low precision. In conclusion, we are trying to say why there may be other indicators that reflect a team's form. The regular season metrics, victories, losses, and opponents' performance are useful in projecting how far a team can go in the playoffs. Thank you.
Thank you very much, Razan. That was a very good presentation. Although you took more than that was a very good one. Over to our judges.
Yeah, thank you, Hassan.
Okay, yeah. Go ahead, Shivam.
Yeah. Okay. So thank you, Hassan. It was a good presentation. Can you just move on the EDA part?
Right, I'm coming.
Yeah. So basically, you are trying to find out the factors which are responsible for the teams qualifying into the NBA finals, right?
Yes.
Yeah. So what would be your recommendations as a final product? Like suppose I'm a client and you would like to recommend me the outcomes of your product.
So I'll say this is a good starting point for a basketball team. Looking at these top features here, we can see not only win percentage contributes to how far a team can go. We can see a lot of metrics concerning the opponents, the three attempts, the field goals, and the efficiency of the opponent. So probably a team would have to invest in signing players to prevent the number of attempts opponents can try, the three pointers attempt opponents can have. So a team's style of play is going to prompt the opponent to try either threes or 2 pointers.
Okay. So you told about the class imbalance problem, like how you solved that. And when I'm able to see your data, it says around 1500 rows. So how did you manage the shortage of data? And does it impact the model performance?
Yes, in this point, we have just about 20% of the positive classes. So for the negative classes, we took a quarter of the majority classes. That's why we have this here. So looking at this with the class imbalance, you can see F1 score. I used F1 score. F1 score is a good metric since we have a imbalanced class, and it takes into context the recall and precision. So after balancing fairly balancing the classes, you can see that the F1 score has improved a whole lot for all the models. However, the true negative rate has reduced. Looking at this column of true negative here and here, we can see it has reduced a whole lot. So there's a trade-off with between the model's performance on negative and positive classes.
Okay, very well. Over to you, Demilola.
So please, can you move to the slide where you have the feature importances?
Importances. Okay, yeah.
Yeah, so please, can you explain the digits that you have on the x-axis? What's the scale? Do you mean the highest feature? Do you mean it's 7%? What do you mean? What's the digits? What do they mean?
The digits is on a scale of 0 to 1. So it is trying to tell us how much each feature contributes to the model's
Exactly what I'm saying. So the highest here, as we can see, is 7%. So are you telling me it's the IS feature is as I'm 7% importance to your data set?
Actually, after doing feature engineering, we end up with about 98 features. And for the sake of clarity, I only chose the top 10 features. I only chose top 10 features. That is why we have a quite low percentage for the most important feature. So what I'm trying to say in essence that 1% is not enough to say a team will make it to the NBA finals. Where you're saying 1% contributes only 7% of the information the model captures.
Oh, okay. I think I get that. So you said you discarded how many features? And how many features did you use?
I did not discard features. I created new
Okay.
features. We did not do
feature engineering.
Feature engineering, not selection.
Oh, that's good. Then can you move to where you have the imbalanced classes?
Yeah.
Yeah. So how did you split your data into train and test at this point? Did you use the conventional train test split? Was that what you did?
Yeah, I used the conventional train test split, and I also checked the class distribution for both train and tests. They were fairly the same, almost 20% in both train and test sets. So there was no need for me to stratify.
Oh, okay. That was what I wanted to ask. I wanted to ask, do you know the difference between that and the stratified shuffle split?
Yeah, there was no need. They had almost the same distribution of classes.
Oh, okay. Sounds good. Yeah, thank you. That's all the question on my end.
Thank you.
All right. Thank you very much, judges. Thank you. Our second group to present, you can stop sharing your screen now.
All right.
Our second group to present is Group Apache, and it will be presented by Mohammed Zahid Habibullah. Sorry for the wrong pronunciation if that was off. And Tomisin Oluwashile. Thank you.
Yes, I'm Tomisin.
All right, Tommy. You have the stage. Your time starts in the next 20 seconds. So I'm giving you 20 seconds to prep your screen. All right.
Yeah, I've not been allowed to share my screen.
You should have such privileges now.
I'm still waiting. No, disabled. Okay, now.
All right.
All right. So my fellow presenter won't be joining us today because he had to do something like he's temporarily indisposed. So I'll be taking this presentation solo. I need to make sure that my screen is visible and you can also hear me.
Yes, we can see it and we can hear it.
All right, thank you very much. So our problem is about crimes against women in India. So our major problem statement and objective was to design a model that could predict the future number of violent acts or like violent crimes that will be committed against women in the regions that were in our data set. So this prediction would be used to take preventive measures or to deploy resources to particular areas so that it can reduce such cases in future. So our process flow is really simple. We acquired data from Kaggle. We had to perform some cleaning on the data. We explored it and we actually created a model that could run the prediction that we wanted to. And then finally we deployed it on Streamlit. So data acquisition from Kaggle, like I said, and then statewide and district level data on the various crimes that was committed against women in India between 2001 to 2014. And then we had 36 unit states and union territories in India. Our data set contained, like I said earlier, data from 2001, 2014, rape cases, kidnapping and abduction, dowry deaths, assault on women, insult to modesty, cruelty by husband, and importation of girls. So basically just seven crimes that were in our data set.
I mean, speed things up. You have limited time, so try and show the
Okay.
important things in your
Yeah,
presentation.
definitely. So data cleaning, exploratory data analysis, some of the things that we're able to derive from our EDA was that we had a very high number of cruelty against women. And it shows that the violence against women has been increasing exponentially from 2004 to like 2014. We also had some plots to show the top districts that had the highest cases of each crime. And then to the model training part, the model was trained to forecast the crime rate for the next 2 years, which is 2015 and 2016. We actually did this because our data, like I said, stopped at 2014. And if you try to predict dates like 2017 to, let's say 2022, the error would be way too high. Like we wouldn't be able to like get precise values. So we had to just predict for the next 2 years. Our data was put in a time series pattern. 14 data points, or you call it time series points. We trained data into training and validation, and we used a simple linear regression forecasting model to forecast the crime rates of each state. So our RMSE value was 17.45. Now, this is a demo of the app that was deployed on Streamlit. So you can view the raw data, which had 11 columns and about 10,677 rows. And then you can select the states that you're interested in. In this demo, I selected a state called Guarat. And then I selected a crime for assault on women, and then 2015.
Wow, you have less than 1 minute.
All right. So when you click the predict button, it's going to tell you Apache predicts 2,031 assault on women cases. And then you can also change the crime to something like rape, and then you get the results. So right here, it predicted that rape is going to be about 1,171 cases by the year 2015. So yeah, that's the end of the slide.
Yeah, so this
Thank
is
you very much.
actually very, very good. Please, can you quickly move to your slide 6, where you did your data cleaning? Your data cleaning.
Yeah, okay.
Yeah, so data cleaning. Yeah. So your point 3. How were you able to handle the lowercase and the uppercase? What did you do?
We did 2 things actually. Like we tried 2 methods. You can just use Microsoft Excel to directly edit the CSV file, but we have a separate data cleaning notebook that we used to convert to convert some of the lower cases to uppercase, because in the raw data set we had some states that were written in uppercase and we had some that were written in lowercase. So
you did not write any Python script. You used Microsoft Excel to rename.
No, we did use a Python script, which is part of our deliverables.
So what did you do? Did you rename everything to the uppercase, or did you rename everything to the lowercase? What exactly did you do? That's what I'm trying to understand.
Uppercase.
Okay. Then for the point 4 as well, what did you do?
Wrong spelling for Actually, in the data set, the RLY was consistent. It was like everything was like RLY,
Yeah, I'm just
just
trying
like,
to understand. Did you rename to the RLY or did you rename to the railway? That's what I'm just
oh,
trying to understand.
we renamed to railway. Sorry.
Okay, very well then. Please, can you move to just move to like I think the end, the final slide or the second to the last slide, where you said you split your data set. Okay,
Yeah.
yes, exactly. So you said this is a time series data, correct?
Correct.
Yes. So how did you split your data into the train and test set for a time series data?
Sorry, I don't seem to get your point. Do you mean like, did you like split to train,
How
test, and
did you
validation?
split it? Did you use the conventional, the train test split? Was that what you did to split it?
Correct, correct. X train, Y train, conventional. From a module from scikit-learn. That was what it, I mean, package.
Sorry, I didn't get that. Did you use the train test split? Sorry.
Yes, the train test split from
Yeah,
scikit-learn.
yeah, but do you know you cannot use train test split for time series data? Do you know that?
No, I am not aware.
Okay, so I think I would like to throw this to everyone, to all the interns. So probably you can like put it in the comments wherever you are watching. So what are like how do you split, how do you undo your training and your data? How do you split it for time series data so everyone can learn? So yeah, so why did you use a linear regression model? Did you try other regressors?
No, we didn't. Because
Why?
from the plots in our idea, we made some plots to see if the data points, if they could, like if a simple linear regression model could fit our data point. And since it could, we decided to go for linear regression.
So you didn't try other models to see if other models could perform better?
No, no.
Okay, so then I think the second to the last question, why did you stick with RMSE as your metric? Did you try other metrics?
That I'm aware of. I'm pretty aware of RMSC, but I'm
Oh,
also pretty sure that we did some other means to check to
yeah,
evaluate
like what?
our
Like what
model.
other means?
This is actually the part that my second presenter was supposed to like handle
Oh, okay,
because
okay, okay.
it was much
That's
more.
that's that's fine. I just wanted to be sure. So then the last question, and this is just by the way, I like your user interface. What did you use to build your user interface?
It was just by default, like not default necessarily, but Streamlit gives you
Okay,
a
it gives you a
really
user interface.
yeah. Like the user interface is just like pretty
All right,
easy to
thanks.
make.
Thanks for answering my questions. That was all for me. Thank you.
Yeah, thank you, them. Like most of the questions you have asked, I just have one question, like what kind of advice for you? Like whenever you are dealing with such critical data, you have to keep in mind that this is the information or the result you are going to throw to the end user is very critical. So you cannot just rely on one model. I would suggest you could have tried multiple models so that you can present your output in a much better way. That's one advice for you.
Okay.
Yeah.
Thank you very
Because
much.
what happens now, whenever you are trying to get the output of such critical situations where suppose you are dealing with this, the output of data from the previous incidents, you need to be very careful about like what models you are choosing in the data cleaning process, right?
Yeah, correct.
Thank you.
Absolutely.
All right. Thank you very much, our judges. Thank you very much, Tomisi. All right. So our next presenter from Group A Priori. Presenting for this group is Prince Emily Faye and Pranav Gupta. Prince Emily Faye, Pranav Gupta. All right. Hello, Pranav.
Hello, sir. Good afternoon.
Good
Actually, it is good
afternoon.
evening in India. Yeah. Should I start my slideshow?
Yeah, you can start your slideshow.
Okay,
Your time starts now.
just a minute, sir. Just a minute, please. Okay. Hello, everyone. I am Pranav Gupta, accompanied by Prince in my life. We are representing a priori group. The dataset given to us was academic ranking of world universities. This was curated by QS, which is a British think tank company. What QS basically does is it uses 6 factors, including academic reputation, employer reputation, faculty-student ratio, number of citations per faculty, international faculty, and international students for classification and for predicting the overall score of a university. The aim of our project was to build a machine learning model to make use of the inputs and to predict overall scores for the next years. We had 3 data sets for 3 years, 2018, 2019, 2020. When we got the data set, the first thing we did was the data cleaning. Here we can see that we have plotted a correlation nullity correlation heat map. What nullity correlation basically implies is that it ranges between -1 to 1, with -1 being that if one variable is present in the data set, then the other variable cannot be present. And similarly, a value of 1 represents that when if one variable is present, then the other variable must also be present in the data set. We can see here that the country, size, focus, intensity, all these are nullity correlation of 0.1, which means that they do not affect the data set with much. Whereas factors like employer reputation score, academic reputation score, these have a nullity correlation of 1, which means that with overall score, which means that if one of them is absent, then the other will be absent, and if one of them is present, then the other must be present as well. Here we have plotted the null values. As we can see, the yellow part shows the null values. As we can see that our data set was filled with null values. How we dealt with null values, we'll be explaining it moving ahead. We had 2 factors here: the score columns and the rank columns. As a decision from the team side, we decided that we'll be using the scores because it provided a better distribution of the continuous variables. As for the data analysis part, from univariate data analysis, we found out that the countries having the most number of universities in the data set in 2018 were United States, United Kingdom, Germany, France, and Japan. And the same order was followed for the data set in 2019 and 2020 as well. The bivariate analysis part, what we did was we plotted all the variables against each other. From this, we can infer that like here we can see that the overall score has a fairly normal distribution, whereas for academic reputation score and employer reputation score versus overall score, as the value of one increases, the value for that increases as well. Whereas for faculty reputation score and other variables, the data is normal. The data is uniformly distributed across the axis. The hue here, like what is color here, represents that the research intensity of the universities. So we can also infer that most of the universities prefer to provide very high intensity programs. Also, we can see that the hue in this graph represents the status of the universities. We can see that universities with orange color, that are status A, were the most dominant in our data set. We also wanted to plot to see how the variables affect the overall score. From here, we can infer that academic reputation score and employer reputation score almost contribute 50% to the overall score, with other variables as well chipping in with little bit of the contributions. Academic reputation score was found out to be the most related variable with overall score with a value of 0.88, followed by employer reputation score and other variables. From here, I'll like Prince to take over.
Hi, I'm Prince, and I'll be handling the modeling.
You have less than 1 minute, Prince.
Yes.
Okay, we a linear regression model because our target data consisted of continuous values. To make our model perform better in real-world problems, we used a combination of complete and missing features. where we assumed that the missing features were equivalent to 0. We also resolved cells in the overall column that had ranges as values by finding the average of each of them. We trained 10,000 models with varying hyperparameters to find the best model, which was decided based on the R-square score, the MAE, and the MSE. The best model was then saved with Pico for easy access and deployment. The model we saved had an R-square score of 0.977, MAE of 2.316, MSE of 8.835, which was pretty impressive. We also trained a different model, this time with 100% features, with totally complete features. But the problem with this model was that it performed very poorly when given a data set, when given incomplete values predict. From our model feature coefficient, we found out that the academic and employment reputation was very significant in the performance of a university's ranking.
Thank you very much. Thank you very much, Prince and Doctor.
Okay.
That was really good. Over to our judges.
Yeah, thank you, Prince. Can you just go back to the observation slide?
Which ones of?
Yeah, the first observation.
Yes, sir.
This
it
one
represents.
Yeah, so just a quick feedback, like suppose you are giving some observations, it should be first of all in points so that it is readable, right?
Yes, sir.
So can you explain me the observations that you made from the project, because it's not clear from this PPT?
So like the first thing that we observed was the overall score of a university was mostly dependent on two factors, that were the employer reputation score and academic reputation score. So like
so
if any
how
module,
did you come to that conclusion? Can you explain me for this?
So first of
and also
all,
this null values graph is also not clear to me. Can you explain to me?
This one, yes, sure, sir. So this graph here,
No,
it represents
the
the nullity.
Next one.
This one.
Yeah.
So the whole y-axis represents the data we have, and the yellow part shows the null values we have. Like yellow plus purple is equal to total records in the data. Purple is the data we have present, and the yellow is the null part.
Okay. Then in your presentation, you mentioned regarding that missing features, somehow you have assumed to be 0. Then how did you got to that conclusion?
Well, for our model to be able to predict missing values, we used 0 because a 0 score means it's not available or it has a very low score. So that's why we
so which means like your data was not having any kind of missing values, or you just assumed it to be?
The
there were
data
so many
set was
missing
having
values
missing
in the
values.
data.
And we trained it on using some of those missing values that had a score.
Okay. So like, can you tell me the size of the data set? And after removing the null values, what was the resultant size?
Yes, sir. The data. So actually, after removing the null values, the data set almost got half. But that is why we didn't want to remove the null values, and instead of removing the null values, we just replaced it with a 0.
Okay. So why you didn't think of having some other methods?
Yes, sir. We could have also used imputers there, but it would have been a very long project then.
And also to avoid manipulating our data sets.
So in last, like what you want to convey through your project is like, what are the outcome of your project? If you can
so
just
like
analyze it in one line.
Yes, sir. So if any university wants to have a good overall score in QS for rankings, they have to focus on primarily two parts of the program, that is employer reputation and academic reputation. If they have a good employer reputation and good academic reputation, these factors are enough for them to get a good overall score in QS.
Okay, over to you, Dami. Thank you.
Thank you.
Welcome, sir.
Yeah, so I'm still struggling with why you guys decided to use 0. to replace the missing value. So are you telling us now that half of your data set contains 0? Is that what you are saying?
No, not really half of the yellow part you're saying is the row that contains incomplete
Yes.
values.
Can you please go back to
like,
the? Can you please go back to that yellow part? That
okay.
visualization.
So we used 0 to signify that it's missing, so that we can pass it to our model to train it on the missing values. And when we tested it, the result it got was very close to the actual values given from each of those rows.
So what you are saying is you left missing values at 0 for half of the data set, because the yellow values is like half of the data set right now.
We left missing values. The yellow values just, yes, the yellow values show the rows. Some of those rows don't, not all the features there are missing, like 1 or 2, but once it's missing, to indicate it as 0. So for each of those
Sir.
missing.
Yes, sir.
Okay.
So what is here? It shows is the null values for each column, but it doesn't mean that when academic reputation score has a null value, at the same time on the same row, faculty student score also has a null value.
I'm honestly still struggling with that, but it's fine. Did you try other methods of imputation?
No, sir, we didn't use any imputer here.
Why? Why didn't you? Why did you just stick with 0? Yeah, I'm still struggling with that.
Okay. Well, we found out that the model performed very well with the 0 values we gave. Maybe, okay, let me see if I can explain it better. The rows you are seeing with yellow contain maybe 1 or 2 missing values. Then the 1 or 2 missing values, we gave them 0 to mean there was no score. That was the way a reason we gave them 0. Now, when you predict anything with using 0 in any of those positions, it will still predict the model. Assuming the 0 just means that there is no score, or it's scored very low in each of those features.
Well,
so we wanted to keep it as real as possible. Like even in real world cases, it happens that there are some missing values. So even if someone puts a column as a missing or 0 in our data in our model, then even then they can get a score.
Okay, so how many models did you use? How many models did you try?
We used a linear model because of our target feature was our target value were continuous values. So we used linear regression.
Just that you didn't try other models.
Some other ones gave us errors, and we did a little research and found out that the best model for us to use was the linear regression model.
Okay. So my last question, can you please go to the data cleaning slide? I think, yeah, my last question. The data cleaning. Yes. So why did you use a missing number package?
So missing number package to find the correlation, nullity correlations.
To find what?
The nullity correlations. Nullity correlations.
Oh, okay, nullity correlations. Okay, all right. Thank you. That's all from me. Thank you.
Yes, sir.
Thank you very much, Tamilola and Chivan. And also thank you, Gupta and Prince Melise. Over to our next group, which is the base group, represented by Vanessa Onyema. Before you come on stage, Vanessa, I would like to reiterate that we have 5 minutes for each presenter to go through their work. So it's imperative you hasten up while presenting, like hit your most important points and just maximize your time. Vanessa, your time starts now. Thank you. Vanessa, your time has started. It's like Vanessa is having some technical difficulties. I would like to call on the next group while we wait for Vanessa. The next group, which is the CAT group, represented by Nasir Ibrahim and Jim Moridwan.
Hello, good afternoon, everyone.
Good afternoon, Nasir.
Yes, am I audible?
Yeah, you're audible. You can take the stage now.
Okay, thank you. I'll proceed to share my screen now.
All right.
Good afternoon, everybody. Welcome to Team CAT's presentation. So, we were given a process which was talking about, in a nutshell, the data sets were taken from a survey of hospital data, and the aim of our analysis was to discover the degree of importance of patient satisfaction determining hospital's overall rating. In this data, for the features, there were features such as the state of the hospital, where the hospital was located. There were also columns which reported the patient's overall satisfaction. There were linear mean values and clarity. So the survey instrument and data collection methodology.
Can anyone hear me?
HCAPS.
Can any?
Go ahead.
So before we talk about HCAPS, I'd like to briefly talk about CMS, which is the Center for Medicare and Medicaid Services, a federal agency within the United States Department of Health and Human Services, which administers the Medicare program and works in partnership with a lot of government bodies. So CMS now, in partnership with the Agency for Healthcare Research and Quality, we created this HCAPS survey, which was used to collect the data. So in our data set now, there were over 4,000 hospitals in the US, which were part of the survey. And we had data from the years 2016 to 2020. Actually, we got the data in form of individual years, 16, 17 up to 20. Now, proceeding to the methodology, patients were required to fill a 10-question survey. As a result, there was 55 survey items in the data set. So each row in the data corresponds to such a survey item. But each hospital now can have many of such survey items because there was more than one question being asked. So we had to, first of all, the first thing we did before getting into any analysis and modeling was to transform the data. So we first realized that there were actually 10 questions that were used to generate these metrics.
Can you quickly move to your modeling? Can you quickly move to your modeling, please?
Okay. So before the modeling, now we administered some statistical tests, which is we mainly considered the Pearson correlation. So we tested this correlation value against the summary star rating. Now this summary star rating is actually the mean star rating calculated from the 10 other questions. As we can see them here, these 10 questions, communication with nurses, and so on and so forth. So as we can see on the right-hand side, we generated the Pearson correlation for each of the different years, 16 to 17. And we also concatenated the data after dealing with the missing values for there was quite a lot of missing data. After dealing with that, we were able to arrive at the correlation score of 0.56. And also we got p-values of 0 across the entire year when testing between hospital overall rating and
Jimo, you have less than 1 minute. 16 things up.
So for our modeling to get as much predictive power as we can from our analysis, we apply the ridge regression across all the features. The reason we mostly stuck with ridge regression is because we want more importance to be given to those features that actually contribute more to the hospital overall rating. And ridge regression is a good way to do that without dropping any features. So for the categorical columns, we encoded them with numerical values, and we dropped the rows where the hospital overall rating value is missing, as this was our target. And we split we did a 70% split.
Jimo, round up, your time is over.
Okay, the metrics we actually looked at the R squared, and we got an R squared value of 0.694 when we used all the columns in the model. So in conclusion, we found that the star ratings, which is a very good representation of the patient satisfaction, is highly correlated with the hospital overall rating. And using the ridge regression model, we observed that star rating is not actually the most significant feature in calculating a hospital overall rating. It contributes, but the other features also play a large part. Thank you very much. I'll now hand over to the second presenter.
Good afternoon. I'll be the one taking the question.
So please quickly move to your modeling, please. Move to the modeling slide. Hello, can you hear me? I said, please, can you move to the modeling? Yeah, okay. So for number one, how did you encode? What kind of encoding did you use?
Can you guys hear me first? So we just use label encoding to encode the categorical variables. We use 0, 1s, 2s to encode them. Hello? Am I audible, please?
Yes, you are audible.
Okay. I can't hear any question. Is there any problem?
Yeah, sorry, I'm back. Hello, can you hear me?
Yes.
Yeah, so I said, what form of encoding did you use for your categorical features?
Yeah, as I said, it's just a normal label encoding, but we actually did it manually because they were not much. We viewed the columns individually and we encoded them manually instead of using the label encoder in SQL or in another library.
Okay, so why didn't you try other forms of encoding like the one-not encoding?
First of all, when we from the starting, we said we transformed some rows that were supposed to be columns, we transformed them to columns. We already had like, let's say 30 something columns. Adding to the complexity of the columns, it wouldn't be that advisable. That's why we chose label encoding.
Yeah, very good answer. Then for the number two, how many rows were dropped?
We dropped like 28% of the data set. That was about 5,000. And the reason why we dropped that was because the output variable, which is the hospital overall rating, there were null values there. And since if there are null values there, I don't think it is any important for us to keep those rows.
Are you saying 28% of your data set is not important?
No, because they did not have an output variable. They had none for an output variable. That means the dependent variable we are predicting.
So you are telling us 28% of your data set is not important?
The reason why, apart from that also.
No, it's just a yes or no. It's just a yes or no question.
Yes, but if you want me to expatiate, apart from it having
All right,
output.
thank you. That's all from my end, please. Thank you.
Okay.
Yeah, okay. So I just have one question, like why you stick with ridge regression?
We tried linear regression also. As my co-presenter said, ridge regression, because we had a lot of columns and we know for most of them, some of them won't be that useful. Instead of us dropping them, we actually use linear regression to perform a little bit of weighting on them, give importance to the ones that will be important and give less importance to the ones that are not that important.
Okay, so just like a feedback kind of thing. Whenever you are presenting, like I saw like in your slide, there are various visualizations, but I think these are not clear. You should take care in mind, like these visualizations should be clear. And secondly, like whenever you are going out there, you should have a proper network over there, so it would be beneficial. Yeah. Thank you.
Thank you.
Thank you very much, our judges. Thank you very much. Up next, we'll call on Vanessa Oyema. Hope you're ready now.
Yes, can anyone hear me now?
Yeah, you're audible.
Okay, sorry for the audio problem. Okay, so good day, everyone. My name is Vanessa Onyema of the Base Group, and I'm here to make a presentation on the Stack Overflow 2020 survey for the Hamoya Data Science Winter 2022 project. First of all, the Stack Overflow is like a question and answer website for professional and enthusiastic programmers, has over 40 million users, 21 million questions, and 31 million answers. The most discussed topics on the sites are from JavaScript to HTML, and the questions asked in this survey actually have helped the creators to improve the Stack Overflow community. This project will aim to provide insight through data analysis in order to answer questions like, who are the developers, and down to what is the average annual income of the developers. These are the contributors to this project. We got our data from Kaggle. Our data had about 65,000 rows and 61 columns. There were also some null values present in the data set, and we explored some correlation and visualization using the independent variables. We cleaned up this data to about 52,000 rows and 36 columns, and retained 81% of our data for analysis. We also tried to see if we can build like a linear regression model in order to like predict salary compensation. And then we focused our data presentation on their demographics, their education, etc. First of all, we saw that over 180 countries took this survey, and the United States had the highest number of respondents, followed by India, United Kingdom, Germany, and Canada. The 53.1% of the respondents were between 20 to 30 years of age. Honduras was the oldest developers by country, and Bhutan was the youngest developers. 91% of the respondents were men, and the dominant race were people of white or European descent. Most of the developers had a bachelor's degree. They majored in computer science, computer engineering, and software engineering. And when they were asked the importance of a computer science degree for developing, they said it was fairly important to as a developer. 60.3% actually wrote their first code between 20 to 30 years of age. They code because they're developers by profession, and the type of developers were mostly full stack and back-end developers. 71.8% of them had about 0 to 10 years of professional coding experience. Honduras had the highest years of professional coding by country, and the years of professional coding by developer was the database administrator. developers learn 39% learn a new programming language every few months. They've worked with JavaScript, HTML, and SQL, and they decided to work with Python, JavaScript, and HTML. They've also worked with the Windows, Linux, and Android platform, and they decided to work with Linux and Docker. Majority of them are employed full-time, work 40 hours per week. 32.6% are very satisfied with their job. 57.2% are not actively looking, but they are open to new opportunities. The men preferred languages and frameworks when choosing a job. The women preferred office environments and company culture, while the gender neutral preferred the same with women, but they prioritize diversity amongst the genders. The database admin had the average annual salary per annum of 200,000 USD. The Republic of Korea had the average annual salary per region. And when we looked at years of professional coding to salary, we saw that the higher the years of professional coding, the higher the average annual salary. We also saw that for a 35 to 40-hour work week, salary was estimated at 70,000 to 80,000 US dollar. We tried to see if we can actually predict salary compensation through a linear regression model. But the challenges we face in this kind of data is that we had dominant test columns. We are also limited to linear models, so we could not explore other modeling. And we had a lot of null values in our data. So we tried to approach this using a linear regression and a ridge regression on a clean data and choosing variables with p-values less than 0.05. We also tried to transform. Okay, we also try to transfer the text columns using the one-hot encoding, but at the end, we couldn't get a good linear model for our data. So in conclusion, this survey actually explores the developer's profile, their experience, the technology they've been able to use for coding, and also their employment status. Thank you.
Thank you very much, Onyema. That was really good. Stopped right on time, at the stroke of time. All right, over to our judges.
Yeah, thank you. So can you just move on to the EDA part?
Okay.
So yeah, just stop over there. So I'm just able to see this 0.4%. So what does it signify?
Okay, it's for the people that
the line that
between
is
15 to 19 years.
Extra line that is going there. What does it signify?
Okay, it's a way for it to be kind of visible, because when it fits into the pie chart, considering that is a very quite small percentage, it will not be visible.
Okay. So it seems to be kind of analysis kind of project. So what are the outcomes that you can say to the end consumer?
Okay, first of all, the creators of the Stack Overflow community created this survey in order to actually know the people that use that platform. They also tried to see the majority groups, like in terms of country or ethnicity and gender, and also the minority groups. This survey was actually taken in 2020. And from looking at the gender, we see that it was mostly men that responded to this survey, with a very small percentage of women and non-binary. So it's kind of saying that. So
the data source is Kaggle?
Yes, Kaggle, that's the data source, yes.
Okay. So can you just move to the modeling part? So yes, so what made you think like you are considering only the variables with the p-value less than 0.05? And why didn't you try some other kind of encodings?
Okay, for what we are doing to convert the categorical variables into numerical variables, we decided to use the one-hot encoding, so it can give you like a range of 0 and 1s. And we also saw that if we try to like feed this into a model, we'll end up dropping like about 3/4 of our data sets, because a lot of the columns had missing values in them. But for this exploratory data that we did, we selected most of the columns that actually had like very few missing values in order to be able to represent the demographics better.
Okay. So you are mentioning over here that data has a lot of NaN values. So how did you handle that issue? And like, what percentage of the data was having NaN values, and how does it affect the model performance?
Okay, from the data cleaning, the 36 columns we chose out of the 61, we're able to drop at least, like, we're able to retain 81% of our data. That means we dropped about 19% of the data that had null values.
Yeah, but can you see like you are dropping around half of the columns?
Not the columns, the rows.
No.
Okay.
I'm talking about the columns.
Okay.
Yeah. So you have dropped around half of the columns. So do you think like the importance of data could have been lost?
No, because some of the columns were actually kind of redundant, because we had some of them salary in their currency, converted salary total, something like that. So we had to actually pick the particular columns that could drive our point. So most of the columns were redundant, kind of, yeah.
So you were saying like most of the columns were not useful for the model, right?
Yes.
Okay. Just a last question, like, how have you evaluated the performance of the model?
Yeah, sorry, I didn't get that.
Yeah, how have you evaluated the performance of the model? Like, how do you think the model has performed?
Okay, because what we tried to compare was like compensation, that is salary of the average developer against some independent variables. So considering that the first challenge we faced was because of the dominant text columns, and we also tried to convert them, but at the end of the day, we were not able to actually predict the model we're looking at. So maybe we considered that it could probably be because the data is kind of like a survey exploring demographics. So that's why we could not really get the
So have you got any plans to improve the model performance in future?
We are still working. We actually have like a notebook on this project where we looked at the model. So we all tried a lot of things, like mentioned here, the ridge regression, linear regression. So we tried to see if we can actually use this to predict, but we were not successful in the end to predict this.
Okay. I would say keep exploring. Yeah, thanks.
Okay.
Over to
thank
you
so much.
Thank you very much, judges, for those questions. All right. On to the next group. We have the Cat Boost group, represented by Oye Olawale Emmanuel and Kedie Adekemi.
Good afternoon. Please, can you hear me?
Yeah, you're audible.
Okay, sorry, I will share my screen now. So my partner could actually start. From there I will continue.
All right. Remember, before you start, you have 5 minutes, so do well to maximize your time.
Okay. Please, I'm not allowed to share my screen right now.
You are, try it.
Good afternoon. Can you see my screen? I'm sharing my screen now.
Okay, good.
Can you see my screen, please?
Your screen is not visible.
No. Not see.
Sorry, I'll have to move on to the next group while you fix your screen sharing privileges. So you'll be presenting after the next group. All right, our next presenters are classification group, represented by Agin Elvis and Mohammed El Awal Arowolo.
Good afternoon.
Good afternoon.
Sharing my screen now. Yeah, so can you see my screen?
Yeah, you can proceed.
Yeah, thank you. So the topic is Arola, and the topic is about divorce prediction. And there is a reason for divorce, and that's what we are to uncover. What makes relationships last or break? And as a data scientist, we work with prediction and speculation, so we need to know if it is possible to predict whether a marriage will fail or succeed. Now, this is the data set having 170 columns and 55 rows, and there are no non values in the data sets. The main target, the column target, or should I say the row target for the EDA is the divorce row. So the divorce column rather. And it shows that we have 56% of the data sets are not divorced, while the other 44 got a divorce. And which shows that there is a more larger percentage of people who are not divorced compared to those who are divorced. So I will stop sharing my screen so my co-presenter starts.
Okay, hello guys. Hello.
Yes, we can hear
Please
you.
go on, you are audible, go on.
All right, so my name is Agin Elvis. I'll be sharing the feature selection bit. So our main problem here in this case was to determine, given a set of questions, are we able to predict if marriage will go on or are those people going to divorce? So what we needed to do first was figure out which are these questions that we need to ask this guy. So we did feature selection with 3 correlation methods and then compared the results. So as you can see from the image, we got, for all the 3 features that we used, we actually got the same number of questions going through all 3 of them. The next one was, all right, so what we needed to do as well was figure out the impact of each of these questions that we had identified. So one of the things we needed to do was to figure out, let's say for like a question like question 42, when I argue with my spouse, I only go out and maybe I never come back. So we're able to determine that that particular question increases odds of divorce by around 280 X factor. That was done for all the questions, and you can see the values over there on the table. Then for model building, what we did, we used logistic regression for this because it was a classification problem. And then what we did was read the data, normalize the data set, and then check the model for accuracy. So in matters accuracy, our model had an accuracy score of 94.7%. And then looking at our pseudo R squared, which is this value over here, we're able to get a pseudo R squared of 0.6. So normally a pseudo R squared, the higher it goes, the better. And then looking at our LLR p-value, which is basically our p-value in this case, we got a p-value of way lower than 0.05, which means of less than 5% of our data was actually being wrongly used. The other thing was now for our demo or our use case. So our model was built in a way that we could be able to ask a couple of these questions. Let me see if I can get that to happen. Can you see my screen? So if I run this code over here, it asks me to answer the following questions truthfully. So I'm assuming we are a couple and we've come for the counseling or anything. So if I'm to give values here, I'll just, due to time, I'll just add them randomly. So I'll say 3 for this value, 2 for this question, let's say 4. I'm using 0 to 4 because we're using a 5-point scale. 2 for this, 1 for, I'm just doing it randomly because of time, just so that we see the output.
Yeah, about time, you have 1 minute left.
Yeah, that's fine. So we see here, when you run the next line of code, we are being told that these people are likely to divorce with a model accuracy of 94.7%. So that's the end of our presentation, and we can actually back these claims by looking at Gatman, the guy from whom this data set was found. We realized that couples who actually gave answers such as question 7, we had strangers who share the same brother and family, where we found that it increased their odds of divorce by a factor of over 500,000. It actually makes sense because at that point, you're basically not living as a marriage. You guys are just strangers. And the same could be verified across all the questions that we actually analyzed. That's the end of my presentation. I think I can take questions from the panel.
Thank you very much, Elvis. That was really quick and good. All right, over to you, Damilola.
Yeah, so thank you. Very nice presentation. So in 3 sentences, 1 sentence per answer, can you give us the scope of this project? Can you give us the findings, what you're able to come up with, and your recommendation from your findings in 3 sentences?
All right. So in 3 seconds, the scope, we were supposed to determine either of 2 things. If I'm given a set of questions and their answers, I'll be able to figure out if these guys were divorced or happily married. The second case was if you get a couple and let them answer these questions that we picked, can we figure out if they're going to stay married or get divorced? The other thing was, kindly repeat the other question.
Your findings and the recommendations from your findings.
Oh, right. So my findings were actually that whenever these questions were asked, and we can actually have a look at them. Let me just move this over to this other side. Sorry, let me move the presentation screen over this side. Our findings were, we get data such as question number 7 here. For passengers or for couples that actually answered affirmatively to this question, where they said we are like strangers who share the same environment at home, we found that these guys were most of the time you'll get divorced. So if you're going to run this code again and then have question number 7 and say it, let's say, a level of 4, chances are that model will predict this as a case of divorce. Same is going to happen for question number 42. So we found there are particular questions that are actually major key factors when determining whether people will get divorced or stay married. And those were, depending on the factors over here, we could be able to determine that precisely.
Yes,
talking of recommendations, so recommendations here for this case will be based on these questions we have over here. We can actually be able to recommend for a couple, if you guys want to get married, let's say, why don't you first come, use our model to run these questions, get the answers to these questions, then you can be able to figure out if you guys are a perfect fit for each other. So if, for example, you guys don't communicate, and that was one of the factors that Gatman actually raised in his research when he was providing this model. He had four horsemen of the apocalypse, and those things were criticism, defensiveness, contempt, and I'm forgetting the other. But if you look keenly, you can be able to see that anywhere where there was lack of communication, like in question number 53, question number 47, these are actually factors that were increasing the rates of divorce. So recommendation would be, come, have a look at the model, run it, see if you guys are actually compatible. If not, then we advise that you guys first go and figure out the modalities behind this, then you come back and divorce and actually work on your marriage, sorry.
Very well, I think you guys have done a very good job. Yeah, so that's all from me. Very good job.
Thank you. All right, thank you very much, our judges. Thank you very much, Elvis.
Thank you.
All right, over to our next group, which was the previous group that was supposed to present. Oye Olawale Emmanuel and Kedia Adekemi.
Good afternoon, everyone.
Good afternoon.
I'll be presenting our data science collaborative team project by the CatBoost team. My name is Adekemi Kadri, and I'll be presenting with my partner, Olawale Oye. Both of us here will be presenting our findings after analyzing the deadly traffic accidents in the UK. On the next slide is our table of contents, which I'll talk about the problem description, after which my partner here will talk about the exploratory data analysis and the summary of our findings. The inefficiency of the road safety system is clearly seen in 2015 as we analyze data from the deadly traffic accidents in the UK. a total of 140,056 cases affecting over 180,000 persons with slightly to fatal injuries were analyzed. That means on an average, we have about 15,000 casualties from accident cases in each month in 2015. Our projects not only aim to understand the key areas that contributed to this accident, but also determine time and location to help us prefer solutions to this problem. Like I said earlier, this data set involves over 140,000 accident cases, with each case being properly described with 32 features, which gives us a proper understanding of the nature of accidents. Analytical approaches were carried out to answer our questions and provide insights and solutions to this problem. From here, my partner Olawale will continue and give us what we came up with on the EDA process of the project.
All right, good afternoon. And I would love to continue from where my teammate had stopped before now. So very quickly, we have
who's that? Coming now.
We have this data set that talks about how sorry, please, my data is working. Okay, we have this actually, and then we're able to see that we have more slight accidents in the United States in the year 2015, as this data set was distributed in a bar chart from with respect to the speed limits of different cars or different vehicles. And we saw that we have the speed limit of about 30 to have the highest, 30 kilometers per hour to have the highest here. And if you look at the distribution very well, you see that across every other speed limit, more of this data set happens to be a very slight accident, followed by a very serious accident, then a fatal accident, which happens to be the least eventually. The next data actually consists of
Hello?
Let me see if he has. Yeah, if he has you might see. It's close to it, but
We can't hear you. You've lost audio.
I'm still speaking. Can you hear me now?
Yeah.
What's going on? Hello?
We can hear you now.
Okay, very quickly, so I'll continue from where I stopped. I said on this chart before this, we have about 75% of accidents from the road, single carriageway roads. So I'm saying that more of the accidents are caused on a single carriageway, which is a road that actually consists of cars moving in opposite directions without anything that they're separating them, no any form of demarcation. So we'll move to the next slide. We talked about a bar chart that illustrates the number of casualties caused at junctions, and we can see that more of the accidents actually were caused at junctions or 20 meters away from junction. So we have to go to this new slide, which talks, this is the bar chart also, which talks about the number of accidents. And we saw that 72% of accidents in the UK occurred on dry land, which means that there was none on any other platform or any other road tracks, but just on dry land, which the next actually like we have wet and damp, and the next type of road track, we actually have frost and ice. So we are saying now that the majority of the accidents were caused on dry land. The next one actually talks about a distribution, as we're trying to show the distribution of our data as to regards different types of accidents. We have this slide, the slight, the serious, and the fatal. And we're talking about how they are affected by the weather condition, which happens to be a natural phenomenon. And we saw that most of these accidents were caused in a good weather condition, as majority of them fell within the fine and no heavy wind, no high wind. So we are very sure that it happened in a very, very good weather condition. So we actually entered a new chart here now, talking about the analysis of light conditions. And we discovered that most of these accidents were caused during the daylight. So it wasn't as if there was any darkness or black light or whatever at any certain time. So actually, move to the next slide, we talked about a pie chart that was about the location of this accident. And we can see that most of the locations of the accident were caused in the urban region compared to the rural region. And this is actually physically true, as most activities, most industrial activities and economic activities are actually in the urban regions. All right, so let's try to understand if the police officers attended the scene after this accident, and we saw that over 70% of the recorded cases, acknowledge the fact that police officers actually attending to the scene at the point of the incident. Now,
Go to the model.
This chart, actually known as an is plot.
Over to you, our judges.
Yeah, okay. So I actually did not really get much from their presentation, but can they please quickly go to their modeling? Can they show the slide for their modeling? Who is their representative? Yeah, if no one is answering, can we move to the next thing, please? Thank you.
Hello, can you take us to your modeling?
Can I come in on behalf of my teammate?
Yeah, you can.
Okay, I'm sorry for that breaking transmission. I think it's having some challenges. Well, during our work, we found out that the data set was complicated, so to speak, and we had a lot of null values and the rest of them. And so we decided to find out if we were to do modeling. And we got a response from the Harmony team that it's actually not necessary and it's not needed. So we could just do our EDA and go ahead. That it's not.
Can you be more audible? Your voice is very low. Please increase your.
I was saying, during our work, we got in contact with Harmony team to find out, because of our data that we had, the data set was not viable for a modeling. And so we are struggling with that, and we got in contact with Harmony team to find out if it was really necessary for us to do modeling. And they told us, the contact person told us it wasn't really necessary, that we could go ahead and do the EDA and present with that, which is what we did. So because of the time factor, we couldn't organize the data set to do the modeling. And so we just did our EDA and presented that, which is what my colleague was trying to present.
Yeah, so sorry, what do you mean that by your data set was not viable for modeling?
I think the regression, we were trying to use regression to work on the data set, and it wasn't really working. And we really didn't have time. So when we contacted them, they told us to just let it go and just focus on the EDA. And we just did that. So probably.
So because one model did not work, you felt your data set was not viable for modeling?
And we were working based on time, so we didn't have time to test other things. So sorry, that's why we just stopped there based on the response that was given to us.
But other teams did modeling, and you guys at the same time.
I guess that's just what it is. Yeah, sorry for that.
It's fine. It's fine. Thank you.
Thank you very much.
Yeah, thank you.
All right, thank you very much, group classification. On to the next group, which is clustering group, represented by Shanmuki Balagames and Chukuma Blessing. Shanmuki and Chukuma Blessing. The previous group, you can stop sharing your screen. Shanmuki. Next group, CNN by Dennis Kemboy and Jonah Uka. Please be ready. Chukuma Blessing Shamuki. All right. We're moving on to the next group, Group CNN, represented by Dennis Kemboy and Jonah Uka.
Hello, Amoye. My name is Kadri Sadiq. I already spoke earlier that I will be taking the presentation for Group CNN. Participants are not around. Can I go ahead to share my screen?
Yeah, please. By all means. All right. Group 9, CNN. All right.
So my name is Kadri Sadiq Kolawole, and I'll be presenting goals and other metrics by Team CNN. And these are our teams. So moving on to the problem statement. So we're given two data sets to work with, and we are to carry out a modeling, to build a model on this data set. And first of all, we decided to use these steps to make sure that we follow the proper actions in order to get a better result in building our models. So we collected our data from Kaggle, and we initially created some user-derived functions, which would give us an overview of the EDA, and also to give us what type of data we have. So after we did that, we found out that we got a bit of, we renamed some columns due to the fact that they were not properly renamed, and also we found out that there were no null data in our data set. But we also during the EDA, we discovered that we had we discovered some outliers, two of them, and since we didn't have any no values weren't needed, there was not a need for a statistical measure to replace those data sets. So instead, then since we got two outliers, and we're able to use the box plot to also, and the describe function to also give us the overview of the data and where those outliers were. So we're able to discover that on the PPDA coef and OPPDA coef features, we saw those outliers, which made us see that the mean and the 75% quartile, the maximum number was very, very high, such that it was over 10 times higher than the 75% quartile in both this OPPDA coef and then the PPDA coef features. So we did also a count plot, a numeric distribution plot, and we saw the distribution, and we also found out that in this distribution, the tail of the outliers were very, very dominant. So moving on, we went into the data processing stage, and we were able to convert the object data type, all these data types that were not integer, because since we know that our model would only be able to crunch and understand numerical data set. So we converted the object data set into numerical by using a manual process. We did not use it's a form of label encoder. We didn't use the label encoder function. We created a dictionary, and we mapped those dictionaries into the features. So we did that for several features, and we moved on to the feature engineering aspect, whereby we used we already passed a date time function, a date time column to make sure that pandas recognizes our date and column as date time. So we extracted so many features from this date time, such as its month end, whether it is at the beginning of the month or the quarter of the month. And we also extracted several other features, such as a month, the year, and the date at which the game was played. So we also extracted several other features using a polynomial feature to with a degree of 2 to further build and expand our data set. And we're able to, from about 37, we're able to improve our data, the features of our data into 147. So moving on to the modeling, we used about 5 models, which are the linear regression, software vector machine, the decision tree regressor, k-nearest neighbor, and the gradient boost. And we used several metric scores, such as the R, the mean, absolute value, RSS, and the RMS. So, and we saw that for the baseline model, the gradient boost regressor performed best out of all these 5 models, which made us select this gradient boost regressor, and we went on with it for the future selection to understand all those features that were pertinent and were very, very strongly related to our response column. So we found out that we had
1 minute left.
Okay, we had about 5 columns that gave us a very good feature. So after that, we went on to hyperparameter tuning, such that we boosted the model gradient boost regression, and we initially used the grid search CV, but it was due to computational capacity and time constraints. We went with the randomized search CV, and we're able to improve our model with this metric score at the end of the day. So I would like to thank you very much. So the conclusion that we got was that due to the beauty of using the grid search CV, we were able to use several data analysis, data collection, processing, feature modeling, and we're able to boost our model to improve it such that it could give us a very, very high metric score, and we could rely on it at the end of the day. Thank you very much.
Okay, thank you. Like, just a quick question, like, how would you summarize your findings? Like, what would you present to a client? Like, what problem solving you have solved and how you have tackled it?
Well, assuming we are the client and we wanted to give him.
How would you relate to the real world use?
Yes, initially we had our data, and we made sure that we were able to build a model which is reliable to predict the number of goals that we would expect in any match. We also built this model and improved on it such that it could, with hyperparameter tuning, we could rely better on its result, such that the RMS values was very, very low, and the mean absolute value also it is very, very low, and all these statistical metrics score measures would properly help us improve our model, and we could rely on it at the end of the day.
Okay, thank you.
Thank you very much. Damilola, do you have any questions for me? On
No,
to the
not,
next.
not any.
All right, thank you, Dami. Thank you very much, Ritik Bola, or rather Kadiri Sadiq, for this.
Thank you very much.
On to the next group, group clustering I was supposed to present previously, to be represented by Ritik Bola. Ritik, hello, you are not audible. Hello. While Ritik fixes audio, we're moving on to the next group, decision tree group, represented by Grace Effiong and Shivam Keshawani. Ritik, please have your audio fixed and you'll be presenting next. Grace Effiong and Shivam Keshawani, decision tree group.
Yeah, hello. Am I audible?
Yeah, you're audible.
Yeah. Grace, are you there? Okay, sir. One of my co-presenters is also there. See, clear. I think she's finding some technical issue.
Who is presenting between you and Grace?
Grace.
Grace.
Yeah. Actually, we both are presenting, so we just share this.
Group deep learning, please start getting ready. By Innocent, Akbareva, and Ajekuma.
Hello, this is group deep learning. Can I go ahead?
Yeah, please proceed.
Okay, can you give me permission to share my screen? Okay, I have now. I'm going to just share my screen. All right. I believe my screen is visible now.
Yes, it is.
Okay, so good afternoon in Nigeria here, and my name is Innocent, and I'll be representing the group deep learning. So sorry, 1 second to just share my camera. All right, so we'll be presenting together. I'll be presenting alongside Ajay Kumar. I don't know if he's available right now, but I'll just go ahead. And for our table of contents, we have introduction. We'll talk about data sets, EDA, models, evaluation, conclusion, and recommendation. So for the introduction, okay, so this project is an application of data science in finance and business, in finance, business, and investment. And of course, I'm just because of time, but we are trying to actually determine how valuable a particular company is based on the data sets given to us. And quickly, I'll just go to the objectives. Now, the objectives, we have several of them here. It is aimed at studying the data set provided and practical application of data science. And of course, the objective is to predict profitability of given company when we consider certain variables. Then the tracking of price trend in various companies and we're trying to compare their performance. Now we're also comparing rolling means with the current price and stock price prediction for the next day. So the methodology we're using for this is we started with data cleaning, and then we did some exploratory data analysis, and then we did a feature selection, and then model building, and we went on to conclusion. Then for our data set now, so we have four unique data sets given to us, and the first data set is the fund. Okay, so we have a prices data set, we have a price split adjusted known as the PSA, and then we have securities, and then we have fundamentals data set. Now, I'll just go quickly to the EDA part. So here we say the EDA begins. Now, the first thing we did is to just check the number of columns, the number of rows and columns in our data set. And you can see that for our fundamentals data set, which is one of the core data set given to us, we have 1,781 rows and 79 columns, while our prices data set, we have a lot more there, and then we are just trying to look at this to compare to compare exactly what we have with our major data set which we are looking at, which is the prices and the fundamentals data set. So of course, here we are still performing some EDA. We are checking for the correlation on the fundamentals data set, which I mentioned is the one of the core data sets we are looking at. And let's remember that this data set has 79 columns, right? So, and this is what we have there. And up next, we are trying to plot a graph here of the trying to just look at what the prices, the current prices are, And in this graph, we are just taking stock price of Alphabet, Apple, and Amazon. Now we are just choosing these specific ones because, I mean, they are big names in the industry and we can easily see the price trends for their stock prices. So that is what we are doing here. Because of how large our data set is, that's why we just decide to just
can you just move to modeling?
Then let's move to, okay, so these are just some concluding thoughts from our EDA. Let me just move. Okay, so this is one of the modeling we are doing here, and we are considering moving averages comparison for Agilent Technologies. Once again, we are considering for 20 days, 50 days, and 100 days. So, and we're trying to see how the price, the change in price, you know, for this particular Agilent Technologies. Then over here, we are actually trying to determine the, so we are trying to determine the EPS of the data of the fundamentals data set, and we are actually employing a linear regression model.
Left.
Okay, we are actually employing a linear regression model to determine the EPS. And over here, this is the reason why we consider the EPS as one of our targets. And of course, we did some dropping before considering this part. And then over here, we are using another model as well. And we are using an RNN model for the Apple company price prediction. And when we use this model, we are just trying to predict what the price for that particular company is, right? And so that we can be able to advise a potential investor whether to go for that stock or not. So that is what we are doing here. And then for one of our final model, which was in progress because of time constraint, we're using a time series to also try to see the changes in price of this data set. Of course, we are not able to complete this because of the time constraint, but we just have to include it as part of the work we have done. And then we also talk about the conclusion and our recommendation. We said companies with higher EPS are generally good investments for future investors, right? Then we think that more research and analysis should be carried out on that fundamentals data sets, and then all models need to be applied on all companies. So in this application, we have done implementation on a very small fraction of the data set, excluding the fundamentals data set, where we are just trying to model the EPS and just determine the EPS of each companies. So that's earning per share when I say EPS. So the time series model is still in progress. So thank you for listening.
Thank you very much, Innocent Akbareva. Over to our judges. Shivam.
Yeah, thank you, Innocent. So I just have a question, like what you did with the data set, like you said like you have 4 data sets. So did you merge them or what did you do?
Okay, so what we did is we considered each of the data sets, and then so the data set has fundamentals data set, and that fundamentals data set has a lot of columns, up to 79. So what we did is we identified missing values, we dropped the missing values from fundamentals, and then we also dropped some of the columns that are not relevant, right? And then we performed some, we built a model around that. So we built a model using a regression, we built a regression model, and we also built, used a time series model to actually look at change in price, right? And then try to study the earnings per share, because from our own study, we can see over here that the earnings per share can be used to actually determine the profitability of a company. And we found that out from a very reliable source. So we are focusing on that here, on the fundamentals. Then for the prices data sets, we actually picked some important companies like Apple, Google, and one more, sorry. So we picked about 3 companies, and we are just trying to determine the price trend. At the end of the day, we can,
Yeah, okay. Okay, I got it. Yeah.
Okay.
Okay then. Thank you.
Thank you very much.
Thank you very much, judges. Thank you very much, Innocent Aquareva.
Yeah, thank you.
So I'm back to group clustering. Ritik Bola, please take the stage. Innocent, you can stop sharing your screen.
Okay.
Ritik Bola, please take the stage. Oh, okay. You're still having the same issues. All right, on to decision tree group.
Okay.
Presented by Grace Efyong and Shivam.
Yeah, yes, sir.
Keshawani. All right.
Grace, please present the screen. Present the PPT. Yes, sister. Yes.
Can you hear me, please?
Yes,
Hello?
you are audible.
Okay. All right. Hello, everyone. My name is Grace Efyong, and my co-presenter, Shivam Keshawani. We are presenting on the project blindness detection. Our project is based on health and Medicare. Our aim is to detect blindness before it occurs with the aid of a machine learning model, which is imperative to the detection of disease for early management and prevention. DR, or diabetic retinopathy, is an issue caused by the degeneration or progressive nature of diabetes mellitus, which damages the blood vessels at the back of the eye. The procedures taken for analyzing this project were data exploration, modeling, and interpretation of results. For the data, we extracted our data from, or we got our data sets from the Aptos 2019 blindness detection data sets from Gaggle, consisting of 3,662 label data sets in trained CSV, having futures ID code and diagnosis with no missing data. We also have 1,928 unlabeled data sets as CSV. The images were labeled 0 to 4, indicating the severity of diabetic retinopathy. From our exploration, we had 1,805 images with no DR, 370 with mild DR, 999 with moderate DR, 193 with severe DR, and 295 with proliferative DR. Over to my co-presenter.
Okay, so we have images, original images of varying shape and size. To bring it into uniform shape and size, we resized it of the size 512 to 512 into 512. Further, to get the required features, we applied certain transformations like green channel separation, contrast, limited adaptive histogram equalization. So what is green channel separation? Green channel separation is used to get the contrast between blood vessels, exudates, and hemorrhage. And CLAHE, that is contrast limited adaptive histogram equalization, is responsible to reduce the problem of noise amplification in the images. Further, we move to the modeling part. We are actually using one of the senior architecture, that is ResNet 50. So question arises, why we are using ResNet 50 here? The ResNet 50 architecture does not need to fire all neurons in every epoch. This greatly reduces the training time and improves accuracy. Once a feature is learned, it does not try to learn it again, but rather focuses on learning newer features. A very smart approach that greatly improved model training performances. So we are using here transfer learning technique, and in transfer learning technique, we are training our model with two epochs, 366 step size and 8 batch size. In top layer training or pre-layer training, we achieved train accuracy of 45.82% and validation accuracy of 46.15% after 2 epochs. After that, in the second stage of transfer learning, we are fine-tuning our model. It changes, what does the fine-tuning do? It changes a model that has already been trained for one task to make it execute for the second related task. So after fine-tuning our model, we achieved training accuracy of 96.17% and validation accuracy of 80.49%. We further move to analysis of the loss function and accuracy throughout the epochs. So one of the most widely used metric combination is the training loss plus validation loss over time. The training loss is used to determine how well the model fits the training data, whereas the validation loss is used to determine how well it fits the new data. So we are using categorical cross entropy here as our loss function, in which after 2 epochs, loss on validation set approaches a minimum, and after 3 epochs, loss declines fast, approaching a saturation range of loss until 13 epochs. Similarly, accuracy
you have
of
1 minute left.
Similarly, accuracy of validation dataset increased rapidly after 2 epochs and kept on increasing till it hits the stopping epochs. Now we come to the model evaluation part. Model evaluation is important to assess the efficacy of model during initial research phases. So it also plays a role in model monitoring. We are getting following this precision recall F1 score for each particular class, and summarized F1 score is 0.86. Another quadratic weightage kappa is a statistics to measure the agreement between two annotators. QWK has been widely used as the evaluation measure for the various medical imaging problems, where the class levels have natural ordering, and we have scored 0.932 as kappa score. After that, we move to the testing part. We are testing our model on 1920 aging images. We are getting 46 proliferative DR and 331 severe DR, and moderate DR 964, mild DR 292, and no DR with 295. So finally, automated screening system significantly reduces the time required to determine diagnosis, saving effort and cost for the ophthalmologists and result in timely treatment of the patient. Automated system for DR detection play an important role in detecting DR at an early stage. The DR stage are based on the type of lesions that appear on the retina. We can review the most recent automated system of diabetic retinopathy detection and classification that use deep learning. Thank you, and open for the question for panel.
Thank you very much. Over to our judge.
Yeah, so I think this is a very solid job done. This is like the first project to do on focusing on neural networks. So this is a very solid work. I would have loved to see the parameters you used to compile your model. But yeah, so can you like tell me some parameters you used to compile? Yeah, so I just want to confirm if you actually did the work. So what are some parameters you used to compile your model? For example, the optimizer, the learning rates, the callbacks, and
yes.
So
we have used Adam Optimizer actually, and
okay.
Other than that, we have used the global average pooling for the pooling part, and then a softmax activation function for our activation.
Okay, so why did you use the Adam Optimizer?
Okay, so basically, see, Adam
yeah, it's fine. It's fine. Did you use any callback?
Actually, Adam Optimizer, we have actually used there also one that I'm exactly not remembering that, but yes, please. Second question.
You didn't use any early stopping or nothing like that.
This one?
Yeah, did you use any callback? That's what I'm trying to understand. Did you use any callback for your model?
Callback, yes. Callback list, yes, we have used callback list.
Yeah, so I think probably you don't. So I'm just asking this because I want to confirm if you actually did the work on this model, and that's why I'm trying to ask this, but it's fine. Yeah, so one final question. On your conclusion here, your accuracy for your training set is 96, but for your validation set, it is 80. So to you, do you think your model is overfitting or not?
No. Actually, it's not overfitting because we have already used the dropout here. We have already used the dropout of 0.5 actually. That's why its model is not overfitting. But like accuracy is very less in case of if you see in the medical implementation. It's 80.16 accuracy because we have used very less number of data. That's why. And when we are training this type of data, then we need actually a large chunk of a large bunch of data set so that our neural network can learn it properly. And to do that, we can also use the data in lakhs, but we are using in only 3,000 data here. That's why it lacks in that validation accuracy.
Yes, I understand, but we can see your training accuracy as 96, and we can see the validation as 80.
Yes,
So
training accuracy.
Yeah, so what this means is that probably your model has crammed your training sets. That's why it is performing, it is giving 80% of your validation. So are you sure your model is not overfitting with this metric we can see now?
Yes, there is difference between the training accuracy and validation accuracy. So there overfitting existing here, I can say that. Because when we have a perfect model, in that case, our validation accuracy and training accuracy should be approximately same. But in our case, it is almost 16% difference is there in the model accuracy and the training accuracy and in validation accuracy. So our model is a bit overfitting, and that we can actually cover if we increase the data set, and we can increase if we increase the number of hooks. In that case, also it can improve in that case also.
Yeah, so yeah, thank you. This is actually a very solid job. Yeah, thank you. That's all from me.
All right.
Yeah, thank you so much.
Thank you.
Shimon, do you have any question for him?
Yeah, I just have one question, like what made you use the ResNet 50? Why not VG16 for mobile net?
Yeah, because in the ResNet 16, we are getting some profit, like some benefits, like it improves the efficacy of the deep neural network, because it skips it, because one solid design I can give, like it skips the connection and adds the output from the previous layer to the outputs of the stack layers, and it makes it possible to train much deeper neural network than the previously possible.
Okay, good work.
All right.
Thank you.
Thank you very much.
And one more thing here, we get another case here, we get the 50 layers of complete neural network now, and 48 convolutional layer, and one max pool, and along with that we also get the one average pool there. And for that, along like we are also using softmax, because softmax function comes with the cross entropy. That's why we also improves our model accuracy in that case.
Okay. Thank you very much, Shivam
Thank you.
Thank you
for your answers and your presentation. On to the last group clustering.
And do you have any suggestion to improve this model? Just sorry, one last question. Hello.
On to our last group clustering, represented by Ritik Bola.
Just due to lack of time, I would just drop a comment for you on for the same. We can just continue.
Oh, all right. Shivam he's going to drop a recommendation for you on Slack regarding your model improvement. The last group presenting today, group clustering, represented by Ritik Bola. I guess they are not. Ritik. Okay, I guess they are not done fixing the technical glitch they have. We've come to the end of today's presentation, and I must say this is just the first half of the series of presentation. We will continue the presentations tomorrow at 2 p.m. GMT +1. 11 groups are coming to stun us again, as this supposedly 11 group but 10 presented today. And we hope that the delight continues. And thank you, our dear judges, Shivam Singrato and Damilola Shobowale. Thank you, our Hamoye fellows. Thank you, our incredible participants, for staying true and making these events more entrancing. And our interns that have made their presentations. Yeah, you are the real MVPs. Let's continue this great journey tomorrow at 2 p.m. GMT +1 with this machine learning weekend. I'll be excitedly looking forward to seeing you all tomorrow. Have a nice day, everyone.
Yeah, thank you very much.
Yeah, thank you very much and have a nice day, guys.
Thank you. Bye-bye. Why this smile? To make you this smile.